Hello dears, right now our topic is complex numbers and we are understanding the important concept of the complex number, that is geometrical application of complex numbers. Now just it's the most basic formula of the coordinate geometry is the distance formula. Now how to find out the distance formula in complex numbers? You just understand this. These two complex numbers z1 and z2 are understood as 2 points in the plane, and that plane is called as argand plane. Okay, now if this point is z1 and this point is z2, then distance between them will be modulus of z1 minus z2. How? You just put the value of z1. Z1 is, suppose z1 is x1 plus iota y1 and z2 is x2 plus iota y2. Then if you apply the values of these two over the formula, then it will become d is equals to x1 plus iota y1 minus x2 plus iota y2 and modulus of this, and that will become under the root of x1 minus x2 whole square plus y1 minus y2 whole square. Now you can easily understand that this is the formula of distance in the coordinate geometry. So in complex numbers, the distance formula will be this only, and what we have done is just explanation of that, nothing else. So you understand, my dears, that what I have written in this formula is modulus of z1 minus z2. I think there will be no confusion in this right now. So the most basic formula in the complex numbers is the distance formula. Okay, then how to find out the equation of a straight line? Now, what are the data which you need to find out the equation of a straight line? These data are, at least you need a point on the straight line, first thing, and second thing you need is the angle theta. Now let that point is z1 and that angle is theta, which I have made in the figure. Then you just take any point on the line z. It is a variable point. Now argument of z minus z1 will always remain constant. So z minus z1 is a complex number lying on the line. An argument of this argument means this complex number will make an angle theta with the x-axis or real axis. Okay, so you can always say that equation of a straight line passing through the point z1 and making an angle theta with the x-axis is argument of z minus z1 equals to theta. I think it's very easy for you. Okay, is there any confusion in this? If you want to find out the exact format of this, then you just put the values of z and z1. What we have to do is z is equals to x plus iota y and z1 equals to x1 plus iota y1. If you'll replace these values in the formula, you will get the equation of straight line in coordinates form. But right now this equation is in complex numbers form. So I think these two formats are clear for you, and try to understand these in the terms of complex numbers rather than converting them into the coordinate geometry. That will be very helpful for you. Okay dears, now you see, just see the next concept. Okay, next concept is the equation of perpendicular bisector. Equation of perpendicular bisector joining the line z1 and z2. Now, as the figure shows that z1 and z2 are the two fixed points. Obviously, these are the complex numbers, and I told you that these two complex numbers must be considered as 2 points in the Argand plane. Got this? Now to find out the equation of perpendicular bisector, what we have to do, see this, z is the locus of a point such that the distance from two fixed points is always equal. And that is the equation of perpendicular bisector. Got this or not? It means what? Distance of z from z1 and distance of z from z2 is always equal. Got this or not? See here, z is a variable point and z1 and z2 are two fixed points. So perpendicular bisector or z will move in such a way that it will always be equidistant from these 2 points. You just see, if your z point is here also, the distance from z1 and z2 will remain same. Now this is the equation. By putting the values of z1 and z2 you can find out the equation. Otherwise what you can do is you can square both the sides. It is z minus z1 modulus whole square equals to z minus z2 modulus whole square. What do you mean by this? It is z minus z1 z minus z1 whole bar, that is equals to z minus z2 z minus z2 whole bar. Clear? You can easily simplify that one. It is z z bar minus z z1 bar minus z1 z bar plus z1 z1 bar. That will be equals to z z bar minus z z2 bar minus z2 z bar plus z2 z2 bar. You can easily cancel out them and you can reduce them into the simplified format, and that format will be like this, that z is z2 bar minus z1 bar plus z bar common, it is z2 minus z1, that will be equals to modulus of z2 square minus modulus of z1 square. This is the standard form of the equation of perpendicular bisector in complex numbers. I think you easily got this concept. You always remember that the equation of perpendicular bisector is the locus of a point such that the distance from this point and this point will always be equal. Okay, dears?